Hey guys, today I'm going to solve a circuit problem. The question here gives us a circuit that has two flashlight batteries, a thick filament bulb and a thin filament bulb. And it also says that the copper wire connecting the circuit elements has a very low resistance. That means we can neglect the resistance of the copper wires. The first question says that calculate the number of electrons that flow out of the battery every second at location A. So electrons flow every second, that is net current, in the steady state. Remember the keyword here, steady state. It also says that in these steady state conditions, the resistance of thick filament is 10 ohm and the resistance of thin filament is 40 ohm. So we need to calculate electrons per second, which is current, small I, is equal to the big I, conventional current, divided by Q in the steady state condition. So we know Q and we need to calculate this big I, which is the conventional current. How do we calculate that? Remember the keyword again, steady state. In a steady state we have two conditions, the current node rule and energy conservation over the loop rule. So we're going to use the loop rule here, which says that the sum of change in potential around this circuit is equal to 0. So the potential around the batteries is 2 times EMF minus potential drop I R10 V equal to IR, we using the Ohm's law, minus IR40, the resistance around the 40 ohm bulb. If we add them together is equal to 0, and we can calculate I is equal to 2 EMF divided by R10 plus R40, and our answer is 6 times 10 to the power negative 2, which is the conventional current. If we put the value in the equation here, we get our I, and we get answer 3.8 into 10 to the power 17 electrons per second. The question number B says draw an accurate graph of potential around the circuit with x-axis running from A to F. Label the y-axis with the numerical value of potential. So this question is asking us to calculate the potential drop among these points A to B, B to C, C to D, E to F around this circuit. And it says start from A and end to the F and label y-axis with potential. So in order to solve this one, we need to first consider where do we start from. We start from A. If we look at this diagram right here, F is positive, A is negative. So our current goes from higher potential, that is positive, to negative. So if we start from 5, which would be what? 3 volt, 1.5 times 2, and A would be what? 0 volt, because the EMF rule says that net should be 0. So if we start from here, from F to E, it is 3 volt. The voltage drops across this 40. So from E to D there is a drop, from D to C there is a constant, and from again C to B there is a drop, and from A to B it goes to constant. So at B it essentially is 0, because at A it is 0, and the voltage here is same. But if the question says the x-axis running from A to F, so we need to go to the opposite. So if we start from A, which we say is 0, so from A to B it is constant, so it goes from 0 to 0, which is essentially constant. So from B to C the voltage increases, and from C to D the voltage is constant, and from D to E the voltage increases, and from E to F the voltage is constant. See, the voltage from E to F is 3 volt, and from F to A the voltage drops to 0. And one other thing you need to look at is the voltage increase or the voltage decrease between E to D and C to B is different. The voltage drop from E to D is bigger because the resistance of the bulb is bigger. So you can check your graph from that too. Okay, and the next question says the tungsten filament in the thin filament bulb, which is 10 ohm bulb, is 8 millimeter long, which is the length, and has cross-sectional area 2 times 10 to the power negative time. What is the electric field inside this metal tungsten? So for electric field, we know that electric field is change in potential divided by length, or the potential drop is electric field times length. So first of all we need to calculate change in potential, which is given by IR, V equals to IR, the Ohm's law. So I times R40, when we plug in this value here, I times R40 divided by L, we get answer 300 volts per meter. Remember, whenever you solve the numerical, make sure you check the units so that you know that you have correct units and thus the correct answer.